In this video, I'm going to continue with the dynamics of motion of connected masses, applications of Newton's second law of motion. I started this in my first video where I looked at the case where there is no frictional force that exists between the two surfaces, the surface of block M1 and the table surface. I also saw the expression, that is, I derived the equation for the acceleration, the common acceleration of the blocks, because if the two blocks are allowed to move, they move with a common acceleration. I also derive an equation for the static frictional force, or the coefficient of static frictional force that exists between the two surfaces. That's the case of a rough surface. Alright, so if you have not seen that video, please, I'll say you quickly go and watch it before you come and follow me in this second video. Now we're looking at the case. Already I've drawn the forces acting. Apart from the weight of block M1, let me include it so I can have the complete free body diagram of this system. Okay, so I have for block M1G is its weight, and the normal force N acts in that direction perpendicular to the table surface, or at right angles to the table surface. Now for block M2, I've seen the weight of M2 that acts vertically downwards, and then you have the tension that opposes the motion of block M2. The tension in the string is the same, since it's the same string we are dealing with. Alright, the motion of M2 is in this direction, downwards. Alright, so here we are to derive the equation for the kinetic frictional force, the coefficient of kinetic frictional force, given that block M1 is a 5 kg and M2 is 3 kg. And with that, maybe we'll find a value for this frictional force. Okay, now let's resolve for the forces. Resolving for the forces acting horizontally. Now, if I quickly put in my coordinate system, any force acting in the direction of the positive x-axis, in the direction of x, to the right of x-axis, I call that my positive. Now, any force acting in this way, in the direction of negative x-axis, of course, that is giving negative. And any force acting upward will giving positive in this case too. Alright, so quickly enough, T minus Fk is equal to M1A. Okay, now I call this equation 1. Then resolving vertically, I have M2G minus T is equal to M2A. I call this equation 2. Okay, now I need to sum these two equations. Summing, adding equation 1 to 2, I have, this is plus for tension. The tension here is positive. T minus T, that gives me 0. So I have my M2G minus the frictional force kinetic, that is Fk, is equal to the sum M1A plus M2A. I decide to factor out my acceleration, which gives me M1 plus M2 is equal to M2G minus my kinetic frictional force Fk. Alright, so that is it for that. Now if I'm to find the acceleration of these blocks, that is, if I'm to calculate their common acceleration, for instance, I'll need to have this one written like this, minus coefficient of kinetic frictional force over M1 plus M2. So that is it. So if I'm asked to find their common acceleration, okay, I have that. Now suppose I'm given the coefficient of kinetic frictional force as 0.3. What's the common acceleration of the block? Let's do that first, and then I'll come back to write the expression for the coefficient of kinetic friction. So their common acceleration, M2 is given as 3 times 10 minus my Fk is mu k times thermal reaction, which is M1G. Of course, if you come here now, my kinetic frictional force is a coefficient of kinetic friction multiplied by the normal reaction or normal force. Okay, so that gives me mu k. My N is M1G, that is equal to the weight. Come here now, the normal force equals to the weight of block M1. Okay, so divided by M1 plus M2, so that gives me 30 minus 0.3 times that is 5 times 10 divided by the sum of the masses, which is 8. That's 3 plus 5. Alright, so I need to evaluate that. That gives me 30 minus, um, this is 50 times 0.3. That gives me 15 divided by 8. So that gives me 15 over 8. That is their common acceleration. Okay, that's their common acceleration. So 15 over 8, 15 over divided by 8 is equal to 1.875. Let's call that 1.9 meters per second squared is their common acceleration. So with this acceleration, the two blocks, and move and all that. Block M1 moves horizontally with this acceleration, and block M2 moves vertically with the same acceleration. Okay, I want to write down expression for the coefficient of static frictional force. Or suppose I'm also asked to find the tension in the string. Given this now, what is the tension in the string? So I can say from equation 1, suppose we are to want to calculate the tension in the string. I'll come from equation 1. Let me take equation 1. I have T minus kinetic frictional force equals M1 times A. Alright, so the tension in the string will be Fk plus M1A. Okay, my Fk is mu k times M1G, which is a normal force, plus M1A. Okay, that's the equation that I need to use to find the tension in the string. So that gives me T equals, I can factor out M1 into mu k times G plus the acceleration. Now this acceleration is what I have here, the calculated acceleration 1.9, and that gives me tension T equals M1 is 5 into 0.3 times 10 plus 1.9. So the tension in the string gives 5 into 3 plus 1.9. That gives me 5 into 4.9. So when I multiply 5 by 4.9, I have 9.5. So the tension in the string is 9.5 Newton. So I've looked at a case where maybe I was given the coefficient of kinetic frictional force. From there, we have found our acceleration. I also found the tension in the string. Now I want to write down the expression for the kinetic frictional force or the coefficient of kinetic frictional force. Okay, let's come back to equations 1 and 2 again. From equation 1 and 2, I have M2G minus Fk equals M1A plus M2A. Okay, so that is the sum when this is the result of adding equations 1 and 2. Okay, so I need to make Fk the subject of the equation. That gives me Fk is equal to M2G minus, I can factor A here, A into what? M1 plus M2. Okay, this is when I rearrange the equation. You take your Fk this way and bring the sum of this way. So that's the expression for the kinetic frictional force. So which means I was given the acceleration to use this equation. And then the coefficient of kinetic friction, that is mu k, because frictional force is coefficient of kinetic friction multiplied by m1g, which gives me m2g minus a into m1 plus m2. Okay, so that my mu k is m2g minus a into m1 plus m2 divided by m1g. Now, let's take our acceleration A as 2.0 meters per second square. In this case, if we must calculate the coefficient of kinetic friction, we must give the acceleration. Then we use our mass M1, still 5 kg. I'll still make use of M2, which was given as 3 kg. I'll take my G as 10. So substituting into this equation, I have 3 times 10, okay, minus my 2, that's the acceleration, into m1 plus m2, that is 8, divided by, this is 5 times 10, which is 50. So this gives me 30 minus, this is 16 divided by 50. So 30 minus this gives me 14 over 50. Okay, so that my coefficient of kinetic frictional force is equal to 14 divided by 50, and I have 0.28. 0.28 is my coefficient of kinetic frictional force. Alright, so this is the expression, the equation for coefficient of kinetic frictional force. And I need to find that. If I need to get that, or if I'm asked to find that, I must be given the acceleration. I must be given the masses m1 and m2, that is the value of the masses m1 and m2, in order for me to determine the coefficient of kinetic frictional force. Alright, so with this, you can even go back and make substitution, that is, they give acceleration. Go back and make substitution to find the tension in the string. Using this equation, you can find the tension in the string. Already, you know this already, and you also know these two parameters. Alright, in the next video, we're going to take more question on this.